Hello, this is Orekoya Olusegun, Physics Mathematics Fundamental on YouTube. Please, before we go into today's topic in mathematics, do not forget to like, share, subscribe, and click on the notification button to have more of my video. Thank you. Today we are taking another aspect of ordinary differential equation, ODE, and we want to solve a particular problem that is called homogeneous type of ordinary differential equation. Now, look at this scenario. If we have this condition, I have this condition. I have this t raised to n, then I have tx and ty as it is now. We assume that this particular variable t is an element of real number such that x and y are also elements of a real number. When we have this condition, then this particular condition satisfies homogeneity of ordinary differential equation. Now, for instance, if you look at this question here, the method called separable variable is not applicable in the sense that we cannot separate variable y from variable x. So another method that we need to consider is to test whether this particular problem can be solved using the homogeneous method. Homogeneous method. Homogeneous method of solution. How do we do that? This particular condition is what we are going to test on this question. And if this condition is satisfied, then we can use what is called homogeneous method to solve this particular problem. Now, how do we do that? First and foremost, this solution now, the step of solution, what we need to do is to make the derivative dy dx the subject of formula. That's the first thing we need to do. This particular question is supposed to be like this in the first instance. So what we need to do is to make dy dx subject of formula by dividing both sides by xy. So we are going to have dy dx. By carrying xy to the other side, we are going to have x squared plus y squared divided by xy. That's the first thing we need to do. Now, we now want to go to test this particular condition. In this case now, this particular one that we have here, we represent it with what we have here. So I will write t raised power n function of a variable x, y, where x is called independent variable and y is called dependent variable. So we equate it. This particular one now, we are going to express what we have here in terms of this. So that means anywhere you see x, multiply with t, and anywhere you see y, multiply with that t. That same t that we multiply here is what we have here, this t. So what I'm going to have here, instead of having I've rewritten it. Instead of having x, y, sy here, I'm going to substitute t there for each of the variable in this question. So instead of this x squared, I'm going to have multiply that x with t. So it becomes tx raised to power 2. Then this y2, we write it as yt raised to power 2. Then divided by, instead of x, you write it as tx. Instead of y, you write it as ty. So if you open this bracket now, according to law of indices, this power will affect each of these elements inside the bracket. So we are going to have t raised to power 2, s raised to power 2, then plus this power will affect everything inside, y raised to power 2, t raised to power 2, then divided by t times t according to law of indices is t squared. So we have t squared, then x times y. So we have t raised to power n that we have here is equal to this now. Now, if you look critically at this particular expression, you can see that t squared is common. So we take it outside the bracket. So we have t squared into bracket s squared plus y squared, then divided by t square into bracket x and y. And t square divided by t square according to law of indices is same thing as t raised to power 0, because when you are dividing you must subtract the power. T minus 2 will give you 0, so this can be written like this. Then we have x square plus y square divided by xy. If you look at this place critically, we can see that what we have here is the same thing as what we have here, and which is equal to this. So now comparing this with what we have here, I have t raised power n function of a variable x, y is equal to t raised power 0 function of x square plus y square divided by xy. Now this particular comparison, that means n is equal to 0. This talk about homogeneous degree 0 of ordinary differential equation of order 1. Why do we say order 1? It's because of this derivative that we have here. The order that we have here is 1 1, so that is why we call it order 1. So since we have already tested that this expression, this question that we have here is a homogeneous ordinary differential equation, then we have a method of solution. That is what I'm going to do in my second video. Please, before we go, do not forget to like, share, subscribe, and click on the notification button to have more of my video. I'm coming to solve this problem in my next video. Thank you. Bye.